Greetings, ladies and gentlemen. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. In today's presentation, we continue with theory of logarithm. With us here is a question from that theory of logarithm. What you need to know as far as theory of logarithm is concerned is to recall all the laws of logarithm. I have video on that. You can check my channels to see the 11 laws of logarithm. And let's look at how we can solve this question. We are asked to find the value of x. If log x to base 4 plus log x to base 2 is equals to 6, what will be the value of x that will satisfy both the left hand side and the right hand side? It means whatever the value of x, we put it here and we put it here. After we work on this left hand side, the answer must be equals to 6. Let's look at how we can solve this question together. If you are coming across this channel for the first time, thank you for coming. The returning viewers, I really appreciate you. I have many videos on theory of logarithm. Theory of logarithm is both in mathematics and general, further maths rather, and general mathematics as well. You can check my video to see a lot of questions that I have solved under this theory of logarithm. Thank you for joining me. Let's look at how we can solve this. And you realize that if you check this question very well, the base here is 4 and the base here is 2, meaning the base are not the same. There are many ways we can approach this. We can either use change of base to solve this problem. Let's look at how we can handle it. First thing to do, write down the solution. We have log x to base 4 plus log x to base 2 equals to 6. Okay? Uh, Here the base is 4, here the base is uh, 2. Okay? So, for me to work on this, this 4 here, I can write 4 as 2 power 2, meaning I'll have the base as 2. Recall from one of the laws of logarithm, if you have log a to base b power n, this is the same thing as, to remove this n here, this is the same thing as 1 over n log a to base b. I can apply this law to this log x to base 4. What does that mean? It means I can write this as log x to base 2 power 2, because 2 power 2 is the same thing as 4, plus log x to base 2 equals to 6. Clearly, the base are the same here. We have 2 as the base here, log to base 2, log to base 2, but I have power 2 here. How can I remove this power 2? To remove this 2 here, find the reciprocal of 2, that's 1 over 2. Meaning, I can remove this 2 by, I will find the reciprocal, that's 1 over 2. I'll multiply this by 1 over 2, then multiply this log by 1 over 2. You realize that this will divide this. I'll be left with half log x to base 2 plus log x to base 2 equals to 6. Okay? The base are the same now, both on the left hand side and the right hand side. You can see clearly here the base is 2 here, the base is 2 here, and we have half. And let me take this up so that we can see it clearly. Let's move here. As I said, we'll be left with half. That will be half log x to base 2 plus log x to base 2 equals to 6. What do I mean? It means I still apply this law here. Okay? If I want to remove this n here, I'll find the reciprocal of n, which is 1 over n. It means if I multiply this by 1 over n, this n will divide this. I have to, of course, multiply this by 1 over n. That is how I come about 1 over n log a to base b. That's what I did here. First thing to do, change this 4 to power 2, then Power 2, that's 2 squared, that's power 2. Find the reciprocal of 2, that's 1 over 2. Okay, so from here, we have log x to base 2, log x to base 2. I can say let y be equals to log x to base 2. What does that mean? Anywhere I see log x to base 2, I'll replace it with y. Okay, so this will be half times y plus y will be equals to 6. Half times y will be y divided by 2 plus y will be equals to 6. Let's clear this fraction. Let's move here to do that. Let's clear the fraction. What does that mean? We multiply 2 by 2 because the LCM of this is over 1 and this is over 1. The LCM of 2, 1, 1 is 2. Meaning multiply this by 2, that will be 2 times y divided by 2 plus y divided by 1 times 2 will be 6 divided by 1 times 2. The essence is to clear the fraction. The LCM here is 2. So we can clear the fraction. Okay? So the LCM is 2. So we can clear the fraction. So let's multiply 2. We'll divide this to be 1. We're left with y plus y times 2. That's 2y will be equals to 6 times 2. That is 12. Okay? So we can add this. Y plus 2y, that will be 3y will be equals to 12. To find y now, we divide both sides by 3. Divide both sides by 3. This will divide this. Y now will be equals to 12 divided by 3 is 4. Okay? So the value of y is 4. But we are saying let y be equals to this. Our aim is to solve for x. So we have to go back to this assumption here. See the assumption. We say let y be equals to log x to base 2. But that's not what we are looking for. We are looking for the value of x. Hence, to find x now, we have to come back to this assumption here. We say let y be equals to log x to base 2. It means anywhere we see y in this assumption, we put 4. So let's replace it. But y is equals to log x to base 2. What does that mean? Let's put y here. We can write this as log x to base 2 will be equals to 4. Okay? So how do we find x from this? Our aim is to find x. To find x, we have to change this to index form. This is in logarithmic form. So let's change this. That's the relationship between indices and logarithm. So to change this to index form, we'll raise this to power 4. So this will be 2 power 4 now will be equals to x. Finally, therefore, x now will be equals to 2 power 4 means 2 times 2 times 2 times 2 in 4 places, which is 16. So the value of x that will satisfy this equation is 16. What does that mean? If we plug 16 here, log 16 to base 4 is the same thing as what? 2. Why? Because 16 is the same thing as 4 power 2. If we take that 2 backward, log 4 to base 4 is 1. 2 times 1 is 2. We'll have 2 here. Let's plug 16 here. 16 is the same thing as 2 power 4. Bring that 4 backward here, it will be 4 times 1. 4 plus 2 is what? 6. Truly, the value of x is 16. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to my YouTube channel at TJ's Maths and Further Maths Adventures for amazing videos.